Alright, these are the notes for Unit 4 of Chapter 1, conditional statements and their converses. So, a conditional statement is anything that follows the form if P, then Q, or the shorthand P with a little arrow pointing towards Q. In this statement, the conditional statement, we have P, hypothesis, and Q, conclusion. Now this statement isn't true or false at the moment. It depends on whether P and or Q is false, and so that can result in four different combinations of P and Q. So you have P true and Q true, P true and Q false, P false and Q true, or P false and Q false. If P is true and Q is true, that obviously means P is true, therefore Q is true. Or if P is true, then Q is true. So obviously this is true. If P is false, then Q is false. That makes sense. If that should be true. If P is false, or if P is false, then, or if P is true, then Q is false. Well, no, because Q has to have P happen. If P happens, then Q has to happen, and here P happened, but Q doesn't happen, so this is false. However, this last one is a bit tricky. If P is false, then, or if P, then Q, we have P is false, so your instinct is that, well, that means Q is false. However, it doesn't mean if P, it doesn't mean Q is the same as P. It means if P, then Q, which means Q could also derive from something else, like if A, then Q, even if P is false. So technically P can be false and Q can be true, and that is perfectly allowed. After we have the conditional statements, we have the converse statement. So instead of if P then Q, it's if Q then P. These statements, even if their originals are true, are not necessarily always true. Like if we have if you are human, oh, this is the P then Q. If you're human, you are an organism. But if we have the converse, Q then P, we have if you are an organism, you are a human. Then you are a human. And this is obviously not true. You can disprove this. Just any other organism other than human, just pointing those exist disproves that statement. Which is why we have our which is why you have to be very careful when you're following converses, because they definitely can be true at times, but they are not always going to be true necessarily at all. So you have if P then Q. There's a few variations you can say on P then Q. You can say P implies Q. Like you could say if P is a power 2, then it is even. So saying P being a power of 2 implies Q, it is even. It's like those type of things. So he's like, this is a subcategory of that. He also says from P follows Q. Or actually, no, that's wrong. Q follows from P. Q follows from P. So yeah, you have P, then that leads to the way that Q ends up. Because P is true, that means the next step would be Q being true, so it follows. Then you could say P is sufficient for Q to be true. So if P is true, that's is sufficient evidence that Q can be true also. And then Q is necessary for P to be true. This is similar to the second one. We have the conclusion started first in the sentence. Q is necessary for P to be true. That is because if P is true, Q always has to be true, because if the chart from earlier, if P is true, Q is true, that's a valid statement, but if P is true and Q is false, that's an invalid false statement. So the only time that so if you want P to be true, and that means you have to make Q to be true to have a valid statement. However, like from earlier, I said that not all the time converses are true, but sometimes you do have situations where you have P, if P then Q, and you have if Q then P as both being valid statements. So like you have, if all the sides of a triangle are equal, then all the angles of a triangle are equal. Like equilateral, equiangular triangle. But there's other ways to express this than just this form. You have 4 forms. The easiest one is this P then Q notation, but you have an arrow pointing both ways. The one that's probably most relevant is P if and only if Q. That means P is only true if Q is true, and Q is only true if P is true. So it's a two-way road. These two symbols basically mean the same thing. If one's true, then both have to be true. Then you can go like kind of Englishy, P then Q, and conversely, Q then P. Just saying that even though this is the opposite of this one, it's still true. Not opposite, but the converse. And then you can have P is necessary and sufficient for Q. This is like combining the necessary one and sufficient one from the previous thing, where only P then Q is valid, but Q then P is not valid. Means P is a necessary statement for Q to be true and a sufficient statement for Q to be true. I believe that's actually all of the notes on this unit. It's a relatively small one, just a few set of logical statements. Bye.